Morning students. Today we are going to see about the machine learning. It's a unit 4 in Introduction to AI subject. First, what is machine learning? We are going to see the introduction, machine learning algorithm, overview, types of machine learning. It is supervised, unsupervised and reinforcement learning. There is a first of. And second of is neural network, introduction to neural network, deep learning algorithm, applications of deep learning algorithm and ethical considerations in artificial intelligence and machine learning. So this is the subject unit 4 syllabus topic. Okay. So first one is introduction to machine learning definition. So it was coined in the year 1950s, okay, by Arthur Samwell only invented this word machine learning. Okay, in the 1950, it is nothing but the self-learning system for playing checkers. He developed that system in 1950s. That is the first machine learning concept. So what is machine learning? So it is nothing but it's a subfield in the artificial intelligence that mainly focus on enabling computers to learn from the data without being explicitly programmed. So what is the meaning? So it is a self-learning system from the training data and improve over time without being programmed. Okay, it is a self-learning system of that particular AI. Okay. This is a history of machine learning. I'll tell in short. In 1940s to 50s only, Alan Turing test was conducted. The proposed the idea of machine learnings from the experience. Okay, everyone know what is Turing test, right? In 1950 only it is introduced, and Arthur Samwell coined the term machine learning in the year 1959 using the checkers program. Correct. So for playing checkers only, he developed the system. It is also developed by the IBM computers. IBM computers only developed that, and we also include the alpha beta pruning test also. We can develop in this particular thing. And in 1960s to 80s, symbolic AI and statistical AI methods was introduced. And 1990s, shift to data-driven approaches was introduced. That is the reinforcement learning concept. And in 2000 only, big data and deep learning evolved, correct? And in 2015, TensorFlow and PyTorch were developed in the year 2016. And in 2020, AI is nowadays in everyday's life, like GPT, NLP, AI powered applications, everything comes in the year 2020s, right? And in present future, we develop the chat GPT system, quantum machine learning, AI regulations, ethical considerations, everything in the present and the future developments of the AI. Now everything is based on this AI. This is a short crisp of that history of AI. So what are the key concepts in machine learning? First, we have to give the training and testing data. So 80% data will be used for training and 20% of the data will be always used for testing in machine learning. Okay. And it contains many features and labels, that is attributes, right? And we have to train that particular model and evaluate that model, which algorithm is you are going to use for that particular evaluation. Everything we have to form under that objective. And finally, optimization, code optimization to minimize the errors and to improve the accuracy if it form. So these are the key concepts. First was training, testing, futuring and labeling, model training and evaluation, and optimization. These are the various key concepts in machine learning. System machine learning working. Okay, so how that machine learning is working? So first it will collect the data and it will prepare the data based on the objective. We have to collect the particular data using any website, free website like Kaggle website or whatever it is. You have to download some data set based on our objective. For example, it is health monitoring system, means you have to download any health monitoring or patient recording system in the Kaggle website, and we have to prepare the data. That is nothing but pre-processing. Pre-processing means it is cleaning and removing unwanted informations and filtering that particular data. That is the data pre-processing. Okay, and normalization. Actually, Pre-processing is cleaning and removing unwanted data, and we have to normalize the data. It will all comes under the preparation of data and training the model. Suitable algorithm have to be developed for that particular objective, and we have to use that algorithm for the objective. Either it is a supervised algorithm or unsupervised algorithm. In supervised and unsupervised, many famous algorithms are there, like K-means, KNN, logistic, reinforcement learning algorithms. Many algorithms are there. Based upon our objective, we have to use some algorithm. That is 80% will be training data and 20% will be testing data. In the evaluation, we have to evaluate that particular model. How accuracy is there, how confusion matrix, how F1 matrix are there, F1 score. Everything we have to determine in the evaluation of the particular model. Okay, and we have to deploy that model. We have to deploy the model for that real world application. How we have to use for the client data. So we have to deploy that particular model using this application. So first one is collecting, preparation, training, evaluation, and deploy. This is the machine learning proper working. And machine learning algorithms, as I said, it is classified as supervised, unsupervised, and reinforcement learning. Supervised is nothing but we are using some labeled data. Already trained data are used, means that is supervised learning. Unsupervised learning means that is unlabeled data. It won't be get trained or having prior knowledge. Okay, at the time only we are going to analyze that particular pattern, hidden patterns, and analyze that algorithm. Okay, that is unsupervised. Reinforcement is nothing but a combination of supervised as well as unsupervised. Mainly it was work on the feedback and the environment only. Reinforcement learning. Okay. So it learned from labeled data, means that is supervised. The examples are regression and classification. Unsupervised means it contains unlabeled data. The examples are clustering and dimensionality reduction. And in reinforcement, as I said, it will react from the environment and get the feedback from the environment and getting the rewards. So example is your games, various games, AR, VR, reality games, robotics, everything comes under this reinforcement learning. So supervised, unsupervised, and reinforcement learning. Okay, so this is another slide which example give a clear cut example of that, what is supervised and what is unsupervised and what is reinforcement learning, and the examples. Here it is example algorithms are linear regression, decision tree is one of the important algorithm, and SVM is nothing but support vector machine, another important algorithm which works in supervised machine learning. Example is predicting the house prices based on the size and location. For example, if it is a 1,000 square feet house, it will have some price. For example, if it is having 2,000 square feet, the price will be differ, right? That is supervised machine learning. Unsupervised means based on unlabeled data. So we have to train the patterns. It will be based on particular patterns and unlabeled data only. So the algorithm is K means clustering and PZA, that is nothing but principal component analysis. So what is the use cases means grouping the customer based on purchasing behavior. So we will in various websites we are buying some products, right? Based on the customer feedback under the customer purchasing, we are grouping that customers, right? When we are seeing any website, any cosmetics or anything, it will be displayed all over the social media, right? Whenever we open any other website, it will come and pop out, and that particular website will be popped, right? So that is based on that particular purchasing behavior and the use cases. And reinforcement learning particularly based on the environment and receiving the feedback from the environment, right? So this a key concept is training the robots or AI. I said, right, in AR, VR games or any other game development, we are using this reinforcement learning concept. This is the various types of machine learning. So this is the key machine learning algorithm, linear regression. What is linear regression? What is decision tree? What is SVM? And what is neural networks? Okay. Linear regression is nothing but predicting the continuous outcomes. That is based on predicting continuous outcome, the house price or various input futures we can give. Decision tree, it's a tree-like structure for classification and regression purpose. In data structures also we will study tree, right? It's also a concept, same concept, decision tree. Okay. And support vector machine. It is a high dimensional algorithm. It is mainly used for complex problems. We can use this SVM algorithms. And neural networks, everyone knows it is inspired by the human brain. And these algorithms is ideal for intricate pattern recognition. Mainly this neural networks is used for pattern recognition streams, right? So once again, it's a crisp format. Classification is a categorical label. The whether you can analyze it either it's a spam or non-spam emails, yes or no category, everything is the classification, right? Regression. Regression means it is a continuous variable that is predicting house prices. In 2010, the house prices, for example, 50 lakhs means in 2025 it will go around crores, right? So that is the difference between continuous variables. And the stock prices in trade market also daily the stock prices will change. Example is gold rate. Regression, so it is used to predict a continuous numerical variable or one or more independent futures. It is again, regression is classified into dependent and independent variable. Dependent means mainly based on the target and independent means mainly based on the futures. Target example house price we can say, and the futures number of rooms or locality in the particular area house we bought, right? Based on the area nearby, it is like metro stations there or any popular schools are there. We will have some different capabilities in this particular future. So this is the various types of machine learnings. Okay, in today's class we see about the what is machine learning and what are the types of machine learning. Thank you.